You didn't sound muted to me.
All right, I'm bigger now and I have audio. I'm not going to question this one. I just know it's true. Thank you. So what I was saying is I am joined now by Dr. Eric Palmer. He is another researcher at the Planetary Science Institute, and he knows how to write software. And this pleases me a lot. And some of you may have even used some of the amazing tools he has created because it's the software that helps us all get, well, some of the data out of the planetary data system. Can you tell everyone here what it is that you do, Eric?
Oh,
And can you
gosh.
maybe sit up?
I
We're
do.
seeing a whole lot of your ceiling right now. We want to see you.
Okay.
You're more
Okay.
interesting.
I don't really know. Okay. So I basically do two things. The first that you were just mentioning is I am the PI of the asteroid subnode of the planetary data system. And so I archive all of the data about asteroids. So that is my job. So if you need data, we have it. And yeah, we've been building tools to try to make it easier for people to get data in and data out. That's actually quite a big passion of mine. The other thing that I've spent a lot of time on, and especially over the last 2 years, was playing Minecraft on Bennu. I I was thinking about it. I build the shape models that we use for flight navigation. So we used
Uh-huh.
images. I used computer software to build computer models of the surface of Bennu. So I've actually been doing the same thing as we're doing with Minecraft right now on Bennu for the last 2 years. We arrived there. I made a global shape model, higher and higher resolution, where we also went down and we built terrain models at 7 millimeters. That was the resolution, so that the spacecraft could actually navigate all the way down and touch down. And as you saw, we had a successful tag maneuver, which was really exciting. But the navigation worked 100%, so that meant that me and my team did a great job. But anyway, yeah, so
You
I've been doing Minecraft for the last 2 years in a way.
That is awesome. And I have to take a moment to thank Kyle out there because he donated enough money that it made our
And
donation total a perfect palindrome. It is 438-834. It is deeply amusing and it is kind of awesome. And you have with you one of our Minecrafters today, I believe. Two of our
actually,
Minecrafters. And
yeah,
you're a third,
they've
I'm
been,
guessing.
we take terms, but they've been working on the rings. So I've been working out all the math for where to run the rings and stuff. They've been doing it. And Anna actually is the one that sat there, has been putting glowstone and carpet on top of it to give you the glow.
It's amazing. I'm gonna totally steal that idea for all sorts of stuff. I love it. I love it. I love it. I love it. Thank you for
So anyway,
being your awesome.
Thomas, Anna. Anyway, yeah, they're actually still working on it right now while I'm talking. So we're
Okay,
taking a
get
break.
back to building.
Well, I'm taking a break. All right, shoo. So anyway, yeah, the other thing is I build shape models using something called stereo photoclinometry, which is where we use images and we use both stereo and the shading of the terrain, different colors based on slope. And we derive out what every pixel's height is, and we build that into the shape model. So we've done it on a whole bunch of things. We've done it on the moon, we've done it on Earth, we've done it on some people have done it on Mercury. We have Atlas and Pan actually done by some friends in APL. That's the Applied Physics Laboratory. Forgot I'm talking to broad people, broad audience. But let's see, Vesta, Ceres, uh, Mimas, a little bit on Iapetus, Tethys, trying to think. Mercury did a whole time too. So anyway, you said you want to know what I do, so there you go.
That is kind of awesome. I kind of love it. And Zenstar has just made the comment of child labor for science. Yes. Yes, it is. And this is
And you can ask
okay.
them. They are. There's all sorts of things I have planned for this weekend, and they seem to be all getting shelved because they're like, I want to do more Minecraft. They're pretty excited.
We're a pretty addictive community around here. Um so so we're here to talk about Mars. And Mars is one of these worlds that when we learned about it in school, it was like everyone just wanted to disappoint us. It was cold, it was dead, there wasn't enough oxygen, and there'd never been water, and it was dry and gross. Don't go there unless you plan to terraform, and even if you do, there's no magnetic field, so it's not worth trying.
Yeah, they tried to paint a really bleak picture, and Mars is actually probably the most likely candidate for some place that we could have a self-sustaining colony.
Yes. And we've made some amazing discoveries in recent years. And I just want you to give us a quick roundup of our current understanding of this little rock with not a lot of gravity that has a whole lot of heart.
Oh my goodness, all the stuff that went in there. Personally, I think one of the most fascinating things are the polar ice caps. It's a mixture of water ice and CO2. They grow, they recede every year. So that shows some really neat cycles that go on. But there is a fair bit of water that's actually locked up there, as well as CO2. They have found craters where, as best that we can tell, we're actually seeing very, very recent flows of water, little channels of water. So we're thinking that that is actually liquid water that persists for a short period of time. They have found underground ice deposits that could be quite a bit of lakes. They've gone back and looked at obviously Maris Varinalis. Help me out here. I'm on camera. I
Uh,
can't speak.
it
Maris Varinalis. Is that it? No, it's
Yeah,
not
I
right.
always struggle to not turn it into an Italian pasta.
Anyway, pretty much formed by expected that it's big waters that we had a dam and it broke and flooded the thing out. There's been work that have looked at large amounts of oceans. They have some detections of methane. Where in the world did that come from? Spirit and Opportunity roving around. They have found pretty. I don't know how pure they ever estimated it to be, but basically quartz, relatively pure quartz sand, which is
Oh,
really,
wow.
really weird.
Yeah.
And then, of course, probably the blueberries is kind of the one I know you were thinking of earlier. And it's hematite, which is it's it's iron, and if it oxidizes, you get magnetite. If it oxidizes more, you get hematite, and if it
Yeah.
oxidizes more, it turns into rust. So it's a mid-level oxidization of iron. And you can actually find it on Earth from time to time. But anyway, those little blueberries, and they believe that that is a strong indication of water. So
That and what gets me is some of the structures that have been found as Curiosity roves through Gale Crater are clearly mud flats that have baked in the sun. And there are structures that look like they could be stromatolites. And it's they're probably not. They are probably not, but that's what they look like.
I think you should define what a stromatolite is for the audience.
I think you're right. Um, a
I'm sitting there going,
stromatolite.
stromatolite. Oh yeah, that's where you get the growth and all that stuff.
So stromatolites are where you get minerals upon minerals, not minerals. You get microorganisms upon microorganisms forming these mats, and the mats grow with the generations, and they essentially end up building layers of stone with their grandparents' bodies. you're a microorganism and you're worried about these generational kinds of things. And as they build layer upon layer, you get these cool, well-defined structures. Those of you who are in Canada, first of all, welcome Canada. Um, your nation has a bunch of really cool stromatolites that are fun to go find. And Canada has some of the oldest landforms on the planet. So basically, you want to go to either Canada or Western Australia, the other group of ancient landforms, if you want to go see some of these things on our own world. And there's stuff that looks like stromatolites on Mars, and that's awesome. So, what are some of your favorite features?
Um, well, I mentioned I really like the poles. I don't know if you had a chance to look at some of the high-rise images. On the
Yeah.
Mars Reconnaissance Orbiter, they got a camera and it gets 20 centimeter resolution. So it's ridiculously high. And the files are like 4 gigabytes big. So it's not like something you can just download really, really quickly. They're these giant, huge things. Um, but they've done these line scans that are, several kilometers long, going through the poles, and they show all the different layers as you go along. So on Earth, we have, a lot of times we have glaciers, but the glaciers have a relatively sharp front because they go through and, you know, it's cold, they move, and then they break off. They either melt or they break off. And so,
Yeah.
you don't get the cool bedding features that you see on Mars. But on the Martian poles, you do, and it helps give you indication of how much dust there was there because dust landing on it makes it darker, et cetera, et cetera. So that's probably one of my favorite because that's like it's active and it's
Yeah.
cold.
And just the fact that the ice caps grow every winter as part of the atmosphere freezes out.
Mm-hmm.
We're not used to thinking of our atmosphere getting thicker or thinner based on the outside air temperature. And to a certain degree, these are things that happen just more so on Mars.
Yeah. I used to be a pilot in the Air Force.
Yeah.
And so we actually did worry about that or think about that because normally the stratosphere is about 36,000 feet. But in the summer, and thunderstorms will build to the top of the stratosphere.
Yeah.
Um, and in the summer, especially in mid latitudes, the atmosphere actually gets thicker because of the extra heat, which gas expands,
Yeah.
and so it gets bigger and bigger. So the actual height in absolute amounts actually changes on Earth from time, during the summer versus winter.
And the
So
altitude you fly at has certain FAA. Well, if you're in the Air Force, that's a different set of regulations, but there's certain regulations about when you're supposed to be flying where in what aircraft. And it sounds like the planet doesn't care about regulations.
no, so flying in southern Europe in the middle of the summer, you can be times where you can't get over the thunderstorms like you normally do. So you have to, kind of zigzag through. But that's actually less about the height regulations and more about oxygen requirements. If you fly too
Yes.
high, not enough oxygen and people pass, that's bad on the good bad
Yeah.
scale.
Yeah. It's the lack of oxygen is the reason for the regulations. um, so looking at Mars, you started this conversation with the fascinating statement that Mars is the most likely place that we could successfully stick humans and have them not die quickly. You
Mhm.
still need buildings and everything else, and you can't just walk around outside if you like yourself and want to live and not break rule two. But what makes it so much more reasonable of a place if you can get there?
So the biggest thing is honestly resources. On Mars, you have carbon dioxide, you have water. Those can be broken. Well, first of all, water is an incredibly awesome resource. We use it all the time. We don't even realize how much water we use in industrial or cleaning, fabrication. So we use a lot of water. Having to import all the water from Earth with the huge launch cost that it is just it's just way too expensive. So being able to get some on Mars is really big. Carbon dioxide, if you bring hydrogen, then you can make methane, which now you have fuel to get yourself home, which is a big thought that people have been thinking about. I think from a very surprising thing is because Mars has an atmosphere and it has winds, you get dust that is rounded. So basically, everyone loves the moon, and look at that. They're like, we should have a lunar colony. Well, one of the problems they had during Apollo, and it's still a problem, is you have a regolith, which is you have rocks on the moon. They get pulverized by micrometeorites, asteroids. They turn into these really sharp rock shards.
And let's
These get
clarify
into
this a
the
bit by adding that there's also volcanic glass, essentially. This is basaltic lava, nasty, sharp rock to begin with, not stuff that cleaves
yes,
off in nice flat flakes.
right, no clays. Yeah, so you have on the moon, you have incredibly sharp rocks and dust. The dust is incredibly sharp. It wreaked havoc on the seals for Apollo, and so on Mars, though, one of the benefits is it's rounded. It's been frosted. It's been bounced around the surface. So all those sharp edges have been knocked off. So that's probably, I think, one of the biggest engineering limitations is the regolith that Mars doesn't have, that anything without any type of atmosphere is just going to be a huge problem. So those are kind of some of the bigger things. I mean, you have the obvious stuff of, you build a dome or you go underground to protect yourself from cosmic rays and any other radiation. I mean, but that's kind of expected.
So we have both Moon and Mars have these lava channels. Both Moon and Mars have water. On Mars is much more accessible. One of the things that really got me reading Kim Stanley Robinson's Red Mars series, which if you haven't read, I strongly recommend, and I'll get a link for everyone in just a couple of minutes. If I were on Mars, the surface temperatures could be warmer than a bad day in Boston. The days that Spirit and Opportunity landed on Mars, I remember just being cold and slightly embittered in my office in Cambridge, Massachusetts, because the temperatures where I was were colder than where the rovers were. And
That's
so
just not fair.
It's just not fair. So if you had a good warm parka and were wearing compression wear so that your skin wouldn't boil and had an oxygen mask, you'd almost be happy. Almost. There's still other issues, but if you accidentally got dumped on the surface of Mars, you'd have significantly more time than if you got accidentally dumped on the surface of the moon. And the not dying as quickly is a rather important attribute. So, have you thought about where on Mars, if you got to go, is the place you'd want to go? Like for instance.
I haven't. I really haven't. So you're going to have to feel that one.
Okay. How can you imagine going there and not pick a place? So one of my favorite random facts about Mars is the atmosphere is thicker down at the bottom of Valles Marineris, which is the not pasta massive valley along the side of it. And so when you look at Mars, there are these three massive craters with Olympus mons, not craters, well, they have volcanic craters in the center. There's these three massive volcanoes, with Olympus Mons being the largest mountain in the entire solar system because the lower level of gravity on Mars allows the volcanoes to build bigger than the higher gravity on Earth allows. And one of the current thinkings is that as all of this lava was coming out, it actually emptied out the world to the point that it ripped open, forming Valles Marineris. And the top of Olympus Mons, you can see the curvature of Mars as you look out at the horizon. And down at the bottom of this valley, you have substantially thicker atmosphere that is still not enough to survive. It's just not. But the thicker the atmosphere, the better the thermal conductivity, the less you have to deal with all sorts of different problems, the easier it is to build equipment, the easier it is to build safe living containers. So I'd kind of want to go to the bottom of that valley and make sure that my solar panels were up on the top of the edge. That's my thought. Oh, I think we may have lost Eric's video. There, now we got you.
Yeah.
You there?
Sorry. I am now.
Okay,
I lost
we
the
had.
last little bit of what you said. You were talking about, the
Oh,
height
I just said I'd
and
want to
going all the
build
way
in the
down.
bottom of Valles Marineris and stick my solar panels up on the edge.
Yeah, that would probably be the best. Um, yeah, one interesting thing I was remembering is um, on Earth we hold on to our atmosphere for the most part.
Hmm.
Nitrogen, oxygen, even water vapor is all heavy enough that it doesn't escape off of the Earth. But
Yeah,
all of the helium that we get when we like mine for oil, um, when it's released to the atmosphere, it's lost for good.
yeah,
It is so light, it is so fast, and Mars kind of has that problem, and it has the same problem for all the things we normally like. So it really don't stay, on the surface for an extended period of time. So if we did bring in a whole bunch of volatiles, uh, we're not going to have them for that long.
yeah. So the sun is a harsher mistress than the moon, but you should read The Moon is a Harsh Mistress at least once. And it's the sun's energy, as Liz Jensen was talking about several hours ago, that with its solar winds, with those coronal mass ejections, it just pushes away atmosphere. And we have the Trace mission out there right now, systematically measuring what is happening with that atmosphere, trying to work backwards and figure out um, just what could have been there once upon a time. And we're learning amazing new details. It seems like every week there's a crazy new awesome paper, often from one of our PSI collaborators, coming out and revolutionizing how we look at Mars. Do you have a favorite discovery that's come out recently?
Um, I think the Sherrod seismic stuff is pretty cool that we actually are doing actually at PSI, and they're finding, different layers of water and ice and stuff. So I think that's probably pretty cool because when it really comes down to it, we need water the most for any type of colony. And, Earth is my favorite planet out of all of them. Anna, she likes Saturn. That's her favorite. Thomas loves Jupiter, but I'm like, I love the Earth first. But if we're going to do anything on off the Earth, we need water. We need lots of water. So
And
those
can you
type of
talk
searches are
to
good.
people about what Sherrod has been up to?
Not a lot. No, they do. I honestly, so we just tagged, you know, was it last week? Earlier it's this week, and prior to that, my whole world really revolved around Osiris Rex.
I
So,
feel that. I feel that. I don't know if you caught any of our earlier broadcast where we were all remembering back to the how do I put this? The summer we forfeited to Bennu. There was the summer of Bennu mapping where I think that all Annie Wilson and I did was verbally berate people, encourage people, throw Cheerios when necessary to get dogs to be cute because Bennu is not cute. Um, and thus we made people map. We made people map. We love those people.
that was a huge, huge effort y'all did. Crazy huge.
Yeah, yeah. Please don't find another asteroid like that. Please.
Well, didn't you see most of them are about like that? So like Riegu looks very very similar in terms of a lot of its structure. So hate to break it to you, but most of them are pretty rock laden. Now the question is do you actually have to go through and map every single one to find a good place to land?
Yeah, and the the we're gonna have Karina Bennett from the OSIRIS-REx mission on in hour 13. This is currently hour 11. So an hour and a half from now, we're going to be joined by Karina, who is on the OSIRIS-REx imaging team. She worked with us on the mapping of Bennu. And I need to hear about how they think the tag instrument essentially punctured Bennu, because all the different robots that JAXA, the Japanese Space Agency, dropped onto Ryugu and the anti-tank weapon that they blew up on the surface of Bennu,
Mm-hmm.
I don't think led us to believe that it was going that Bennu was going to be quite this
Soft.
crunchy.
Yeah. Friable is a good technical term.
See, friable just makes me think it's made of like kettle popcorn. Um, so although
I'm
given the
giving you a
way
good
it
geology
behaved,
tech term.
I know. This is the problem with being an astrophysicist who works at a planetary science institute. Um,
I'll just caveat one thing. Geologists love having all sorts of like obscure terms that almost describe the same thing only slightly differently.
okay,
So
that's fair.
don't feel bad. They come up with a huge number for subtle distinctions.
Whereas in astronomy, we just give things really bad names that no one can make sense of, like dark matter and dark energy have nothing to do with one another. Absolutely nothing to do with one another. We're all into the confusing people. This is just the
Also,
way it
like how
is.
astrophysics physicists like to ignore factors of two and
Oh,
round
yeah.
everything to convenient factors of 10.
Yeah, didn't you know the speed of light is 1? You just have to pick the right set of coordinates and everything becomes much easier.
Exactly.
Uh, all joking aside, in the past just 2 years, we've seen evidence of tsunamis, of flooding, of so many other water
Mm-hmm.
effects. There's some evidence that impacting asteroids sloshed mud.
Mm-hmm.
What do you think is the limit on what Mars may once have been like?
Well, I mean, they have relatively, I think, pretty decent evidence that there was, standing water on Mars for a period of time. I don't know if it was when there was enough volcanism to, push up the atmosphere and to keep in it, to have enough radiant heat to keep it all liquid. But they did at a period of time, some relatively large oceans and such. So it kind of seems like you had an active hydrological system on Mars for a period of time. So not so much now, though, sadly.
It really makes me wish that we had a time machine instead of a police box filled with jasmine tea, um, so that we could go back to that time a billion years ago when potentially Venus was an ocean world, Mars was an ocean world, Earth was an ocean world. To see these three rock flinging planets that have shared debris with one another, to see what
Mm-hmm.
was going on in each of these places. And it makes me kind of angry that time travel doesn't work in that direction.
Yeah, it only goes one way and kind of slowly at that. You bring up an interesting point, though, is if you have a bunch of inner solar system bodies that have water, the
Mm-hmm.
standard formation mechanics that you would expect is the inner solar system is going to be dry. But we've been looking at asteroids and comets to be the source of a lot of the water coming in. And so if you do go back to the great cataclysma, you know, you have all sorts of asteroids coming in. If they're where we got the water on Earth, or then they could very well have been providing the water for Mars. Of course, Mars not having strong enough gravity, they'll lose the water there.
Yeah.
So
And the thing is, we have found pieces of Mars on Earth.
mhm.
I don't know, and maybe you do, if we've ever found something that we believe can be attributed to Venus on Earth. I just don't know if that's happened.
Yeah, none of the meteorite records have anything that I've seen people map to the Mercury or Venus. I mean, we think we got the moon, we think we got Mars, we think we got Vesta. There's a few other parent bodies that they're kind of like, I think like the L chondrites are coming from here, but for the most part, we're still really kind of iffy. So on that.
And the thing is, we know that Mars has suffered major impacts because we can see the basins.
Mm-hmm.
We know Vesta has suffered major impacts because it got squished. It's no longer a sphere. That was one heck of an impact that changed its rotational axis so that the crater became its south pole. It didn't get cratered in its south pole, luckily. That would just be rude. Um, so with these worlds that have clearly undergone massive impacts, there's a chance that we've shared all manner of stuff between each of these worlds. One of my favorite quotes was in a Scientific American article where it said underneath your standard graphic of asteroid coming in with dinosaurs, it said and I'm paraphrasing, the shockwave from the asteroid impact launched rocks, dirt, trees, and dinosaurs at escape velocities. So the first massive life forms to exit our planet's gravity well were very dead dinosaurs. Very dead dinosaurs. And we lost your video. There, you're moving again. Are you there?
I heard about that long ago. Wonder.
Oh, we're having
Uh,
technical difficulties.
okay.
Yes, Lil Bizzle dinosaurs did beat us
Guess
into
my internet is
space.
it should.
There. Okay, I saw your eyes moving. All right, can you speak, Eric?
I can't speak. Woof, woof.
Okay, we have you back. So we've had the fabulous conversation of wait, dinosaurs beat us to space, followed by lumps of flying meat, nice, followed by fossil fuels flew, followed by space dinosaurs, and someone else was like, in response to dinosaurs beat us to space, Armstrong said not in a way that should make us jealous, though. Um, yeah,
Exactly.
yeah. This is an accurate depiction of things. So,
And isn't it a dog and a monkey beat us to space anyway?
and a cat, and some
A
other
cat.
things, I'm pretty sure. There was a cat. I forget who sent the cat. There was a cat. There was
Oh,
recently a celebration of the anniversary of the cat, and they shared pictures of the cat, and it was quite pretty. Um,
poor
Sadly, I
thing.
don't remember more details. Um, all sorts of animals have been sent to space, including a very confused frog on the International Space Station. If you have that much jump, you don't belong in zero G. Um, so with Mars, we also have these two little tiny moons that have much debated formation mechanisms. I think it's
Hmm.
safe to say we don't know how they formed. Um, but one of them's eventually going to shatter and potentially form a ring.
Hmm.
Can you say anything about this as your kids are off building rings in Minecraft?
Um, well, I think it's Phobos that's inside the Roche lobe, and so
Yeah.
gravity is pulling at it, and you actually can see on the imagery some cracks. It looks like it's actually being pulled apart. The regolith on top is kind of falling into the cracks a little bit, so you get these ridges, and that's sort of one of the things that's expected. But yeah, at some point it's going to supposed to break apart, and it will, at first it's going to be a big glob, and then over time it will different pieces are going to get elongated out until it finally forms a ring, so that we have a ring around Mars, which would be kind of cool. But of course, it's going to also decay even further until it, you know, burns up in the atmosphere or slows down and settles to the ground or so. I don't think
It's
it'll burn in.
probably going to be a combination. There's a few objects out there that we've seen ridge lines around them that appear to be the debris of fallen rings that essentially fell out of the sky of these objects.
Yeah.
Um, Things crash and fall apart. And Phobos is a lesson that not all worlds are held together by gravity. It's also just a rock that is holding itself together through chemical bonds the way good minerals do. And at this point, gravity is working to break the chemical bonds as much as it's trying to break the gravity. And we're going to get pieces. We're going to get pieces, people.
The sad thing is we probably won't see it.
It's true, but it's
It
fun to
would be
think
pretty
about.
spectacular to watch. Yeah.
And this brings up the sad fact that you can always tell if a moon is going to crash or if it's going to migrate away based on the rotational periods of the two objects. If you orbit faster than the rotational period of what you're going around, you're eventually going to migrate in. If you go around slower than the rotational period of the thing you're going around, you're going to migrate away. So our own moon will never turn into a ring. It's just going to drift farther and farther away. Random facts.
It's drifting away from us.
It is. We're no longer loved. So
Yeah.
our Instra has pulled up information on the first cat in space, which has recently
Oh, excellent.
gotten a memorial. Felicity, first cat in space, has gotten a memorial to their suborbital mission in 1963. Felicity was a former stray sent into space by the French. By the French. We always forget that they had their own live creatures getting launched space program. They just never followed through to be launching humans on their own rockets. The European Space Agency is a conglomeration of the efforts of many different teams from many different nations. And they do amazing stuff. And they launched a cat in 1963.
It just doesn't seem nice.
I'm not sure who it's worst for because somebody had to try and put that cat in a spacesuit.
Yeah.
So, anyways, there's now a discussion of how Taco Cat is Taco Cat no matter which direction you read the word. And I can never unsee that. And our donation is still a palindrome, which makes me somewhat sad because we need more donations. You're welcome to donate more that keeps it a palindrome or just donate. Um, and there was a request for how do you say pigs in space in Russian? And I think that that was because the person knows that I have watched the Muppets in Russian, and it is Shvina va Kosmosia, which I enjoy saying far too much. So we are slowly running down on time. We have about 6 minutes left, and we've been focusing largely on Mars, but we have a lot of people in our community who love to go and get data, play with data, make beautiful images, make VR landscapes to explore. And these are all the kinds of things that I'm pretty sure you can help them with. How can people go get some of these amazing shape models and other? Thank you for the donation that just came in. Who was that? Oh man, thank you, Georgie, for the $50 and $1.45 covering our fees. Thank you so much, Georgie. So where can people go to get data like the shape models that you were discussing earlier?
Um, so the official answer is the PDS. So pds.nasa.gov will get you there. If you want shape models, believe it or not, you can go to SBN, Sierra Bravo November, at psi.edu, and we have several links, and one of them is shape models, and we have one of my programmers, Connor, has actually spent a bunch of time getting almost every shape model we can get our hands on. So we have asteroids, we have moons, we have whatever we can. And some of them are radar shaped models. Some are from light curves, meaning that we watch the asteroid far away and we see how much the brightness varies over time, and then we mathematically calculate out what shape had to match for that variation in brightness as it rotated. And then, of course, we have some from stereo or stereophotogrammetries, but we have all of those, and we actually have ability that you can take your phone, and if you select that on your phone, you can bring up the little thing in augmented reality, and so you can take it and you can tap your phone. Looking through the phone, you can have that asteroid there in your living room, and you can like walk around it and get physically closer to it as you're looking at it through the phone. So it becomes an augmented reality object in there. So we have a lot of those.
Super cool.
So if you want shape models, that's kind of one of the big places for that.
So I think during one of our community coffees, which we do on CosmoQuest X on twitch.tv, I usually spend my Thursdays doing behind the scene things, playing with technology, things like that. I think I need you to come on so that we can all walk through putting asteroids in my basement studio together. This sounds like something that needs to happen. So with just a couple minutes left, where can people go to learn more about all the awesome things you're up to, and what are you planning to work on building next in Minecraft? Did you hear me?
Yes, I'm trying to think. I'm not very social media-ish, so I don't have a Twitter. Actually, technically, I do have a Twitter account. I've just never tweeted. So basically, look in the academic literature and you'll see some of my stuff. I hate to break it to you. There's not a lot of public stuff.
I think the correct answer is go to psi.edu and see what my team and all my colleagues are doing at the Planetary Science Institute.
Oh, that's a much better answer than mine. But I can't answer the second one. The second one's easy. Right. We're going to go work on the rings some more.
That's awesome. So I can't wait to see what you and your kids are putting together. Are you releasing anything at the Division of Planetary Sciences conference next week?
No. Pretty much we're waiting on the official releases of the shape models through the mission is where that data will all kind of come out. So
and when those go live, we're kind of addicted to Bennu. And so we'll be covering it on the Daily Space. And we may ask you to come talk on the Daily Space about those shape models.
I can do that.
All right. So thank you so much. We are next going to Mines on the 49. And I suspect we'll be taking a look at the rings you and your kiddos are in the process of putting together. So I'm going to let you get back to, well, blocking.
Lots of that.
Okay.
All right, thank you.
Bye-bye, Eric.
Bye.
Okay, I have audio. Do you have audio, Keeper?
I have audio.
Okay, awesome. We actually pulled it off this time.
Do they have audio? There's the question.
They do.
All righty. So here we are. We're at the Overworld Welcome Center, and there has been some developments. I'm floating around in the air here, so
And I'm going to turn off my video and desperately shove egg into my face. Thank you all
you do
for
that.
pardoning me while I do a bit of munching.
So we've got some construction going on the launch pad here. This is new in the last little bit. I think we have a player called there they are. Sparkle 309, who is building something that will be going off to space. Oop, I see someone has added a blue block. We have I believe this is a large model of Bearsheet, the Israeli lander that went to the moon. We've got the large observatory up here, which I will spin around and show you in just a moment. And as you can see, we've got the telescope installed. And we have a space shuttle. Just, parked on the grass as you do with your space shuttles. We have the ever-growing library, repository of all knowledge, something going on here. For a second, I thought he was making a giant record player, but it doesn't quite look like that. And now let's go to space. We are landing in the middle of the sun. And we'll just do a quick visit to Mercury, which is very nice. It's nicely coming along. And we will next go to Venus, where we can see, we can see Kieri applying colors as we speak, working on the surface of Venus. Next up, we've got the planet Earth. Yeah, there it is. Earth is 26 blocks in diameter, so it's not a small thing in Minecraft. There are a couple little bits that need to be added, but it's coming along. We do have Australia, so that's good. We can have a little peek into the center of the Earth. If I can get through the door. No, maybe not. They may have glassed it in. But anyways, you can see the center of the Earth. We've got molten material in the center of the Earth, which is accurate. We've got the North Pole with its sadly ever shrinking ice cap. And of course, the Earth would not be complete without the moon. And the moon would not be fully complete if it didn't have an Israeli lander hopefully landing on it. Oops. Back to the center of the sun. Now we're going to go and visit Mars. Oh, hello, Shadow Wolf 583, one of our builders. And if you were watching last hour, you saw that we have a little blue police box in honor of our friend Paranor. And of course, the Mars would not be complete without some potatoes. And a volcano. That's as close as we could get to being to a volcano. And Phobos is here. And Deimos is somewhere way over there, but Deimos doesn't have a label, and I have yet to find Deimos, but I know it's there. And so now we have some new, and I don't know if Pamela is back yet, but we have some new builds. We're starting to install the asteroid belt. And look what we have here. Oh, we have Miss Kitten.
There is a Ms. Brick Kitten. There are rocks.
And so we have Bennu. It is not to scale, because if it was, it would not really register. But Bennu, whoops. Bennu is a little pyramidal thing. In real life, it's been described as being a giant D10 that spits rocks at you. So many rocks. And of course, you have to press the button on Bennu, because that's how we're making all these little rocks. And down at the bottom of the screen, you can see that it actually speaks. Oh, and look at that. We have a blue square. And the other thing we have for you, Pamela, well, maybe not. We have a button that says teleport to Ceres. And it appears to have taken me back to where I am. But Ceres is out here somewhere. Up there it is.
Yay, Team Ceres. Go Ceres. Did you build Ceres out of dead coral?
The other former planet besides Pluto. Back to the center of the sun. Out past the asteroid belt, we have Jupiter.
Oh, wow. Now, do we know if it looks like a skier on purpose?
And clouds and the things that one can see in the pattern of the clouds.
So, sorry, you didn't hear me on that. Do we know if it looks like a skier on purpose?
No one has answered the question.
But I'm not the only one who sees that, am I?
I don't know. What does chat think?
Either that or someone who's conducting an orchestra in white tailcoat and two batons.
Could be, or they could be standing on a giant slug of some sort.
And we have Hexacosacoron piping up, skier was not on purpose. All right.
Right.
I continue to see a skier.
Uh-huh. I'm just going to go... Looks good, guys. Where are we going after Jupiter? We will go to the planet... the planet with most of the rings and many moons.
I can still hear you, but I'm going to go refill my tea kettle. I will be right
That's
back,
okay.
everyone.
So we've got Saturn with its growing collection of rings. And I'm going to zoom out here, go way, way, way up. Give you an idea of the scale of this model. So you can see the rings are all roughed in with all those little marks are the divisions between the various rings. And we've got rings being filled in, and there's really cool lighting. And I don't know how much farther up I can go before I go at the top of the world. That little circle is our building platform. That's where we have our palette of blocks that we're using, and the button that we press when we want to go back home. And of course, after Saturn, we're heading off to Uranus. And Uranus is blue. Very, very blue. I know they have an image of Uranus, which they're going to use to put in a few features. There aren't a lot of features on Uranus to start with.
There's a few seasonal clouds, but we only get those seasonal clouds, I think, during the I don't know how to adjective Uranus, during Uranus's equinoxes.
Sure. And of course, the obligatory teehee.
Yes. One of the most awkward interviews I ever gave was on the pronunciation of Uranus from a airport lounge, and the business travelers sitting about me in the area where you're allowed to talk on your cell phone were just deeply disturbed by the fact that I was going Uranus, Uranus, all these different pronunciations. So this is a world that elicits laughter no matter who you are.
So apparently, the North Pole is roughly here, according
Excellent.
to this little sign. And the sun is that way, so far away that there's no possible way we could see it. Even if we loaded every chunk from here to the sun would probably appear to be like a pixel in
Well, and that's
Minecraft.
realistic. From Uranus, the sun begins to look to the human eye like a barely extended object. A very bright
And
one, but
so apparently we've got Neptune's color palette over here, and for reference, Uranus's palette. I guess they're trying to make sure that they're not exactly the same, because they aren't. And this looks really cool with it looks like it's some sort of glass,
yeah.
and then a few non-glass things up here, some white. Oh, and there's
Hex.
Hexacosacoron, one of our Minecrafters,
And a professional artist. So
and
it's
a
kind of
professional
cool that he's
animator.
in here. Yes.
Yeah, Noel Hexacosacoron is an animator. He actually made the skin of my character.
And mine.
Yes. So we look like Noel thinks we look.
And I approve.
Yeah. And last but not least, we have Pluto
Is there a
with its
hole in
heart.
Pluto? Oh, that's its heart.
We'll
Figured
go
out how to
around.
give Pluto a heart.
Oh, it's been there for hours.
I didn't rotate it in my brain to understand what it was until now.
Yep,
I'm a
being
little slow
Minecraft, we have to
occasionally.
deal with blocks. We can't sort of rotate things easily.
Yeah.
So that's as good a heart as I could come up with for Pluto.
I'm fine with this. And there's Sharon.
And there's Sharon.
Awesome. There's so many more ravioli moons in Minecraft than there are in the real solar system, and the real solar system already had plenty.
Yep. And so we are in the process of we're adding in more of the very small bodies.
Awesome.
Yeah.
So what are you going to be working on building next?
I think I might actually go and take a little break.
Well earned.
Yeah. But providing input behind the scenes and doing some calculations to help position all these little these asteroids. I think we're putting in something like 43 objects, if I remember correctly.
Wow.
Um,
That's
yeah.
a lot, and that's kind of awesome.
Yeah.
All right. Well, I'm going to let you go